sponsors where they have put together a really good presentation, one of the largest IT conferences in Sri Lanka. So which is very exciting. And just after the lunch, so I hope I won't make you sleep 1 hour. I want to make this session a more interactive one, where you can ask any questions, and then we can build the conversation on top of it, rather than like me talking 1 hour at stretch. So today I'm planning to discuss about DevOps, a study in DevOps, broken walls and emerging bridges. That's how I wanted to call it. I will explain why throughout my session. So first of all, I want to discuss more on what DevOps is. Before that, we need to identify why we needed to have new practices, new way of working as DevOps. The first thing is like in traditional software industry, if you have been in waterfall software development companies, waterfall software development projects, if you have been in, you would realize the pain that people are going through when we are trying to deliver the software on time. The biggest bottleneck was if we gather months, we gather the requirements months, and then we come up with some sort of a understanding on the software, and then we started to build it in a waterfall method, and then we deliver it after another year's time. Yeah, pretty much the entire crowd, entire community here are like now moved to agile software development. So the benefit of this agile software development practices are we were able to deliver software on time, and basically the most important thing is we were able to slowly evolve a product into its desired state. For example, unlike in a waterfall method where we do all the development and release it at once after say every 6 months or maybe yearly, we were gradually releasing. In agile practices, in every iteration, you should be ready with at least shippable set of code that can add value to the customer. So small incremental changes were introduced in agile practices. So that is the biggest advantage that we got out of this agile practices. When these development teams are pushing smaller changes to the production environment, they were always changing the production environment and introducing smaller features to the product. On the other hand, traditional system administrators, operation engineers, network engineers, DBAs were having so many issues because their focus was not on changing the software rapidly. So with this movement change, with this paradigm shift change in agile environment, the biggest problem that the industry faced was the environment instability. Production environments were not stable. Due to many reasons, every time we introduce a change to the production environment, every time we introduce a new feature to our product, every time we introduce a bug fix to our product, things are getting breaked. If you change the network card of a server, the production environment get breaks. So if you take the number of production incidents that you are facing, most of them are occurred due to changes. That's because the one part of the world was agile and the other part of the world was not agile. They were doing their old traditional sysadmin work. When the agile teams were having a shippable set of code after every iteration, we were not able to successfully deploy it into the production environment because the other part of the world was not ready to accept that. The other part of the world is the operation folks, people who manage the production environment. So that is the biggest problem that we were solving with these DevOps practices. So with DevOps, breaking down the wall of confusion between development and operation and extending agile practices and values from the development to the operations, which is very important in delivering the software on time. So we need to extend our agile practices into the operations world as well. So I want to explicitly mention one thing. If you are only building a product and you hand it over and wash your hands after that, then sometimes these concepts might not make big sense. But if it is software as a service, if you are providing software as a service, and if you are owning the entire support cycle of a software, which gives a lot of value to organization with these concepts like DevOps. So the other thing is automated configuration management tools like Chef, Puppet. Using configuration management tool is also one key aspect of DevOps. In modern world, the provisioning infrastructure is easy, but compared to like 5, 6, maybe 10 years back, if you want to add new servers to your product, what you have to do? You have to go through all sort of hassle, like you have to get quotations for the servers, select the best price and get the servers into the data center and install it and have them configured, and then deploy your code into the production environment, which creates a lot of issues when we are trying to deliver on time. So that because of that, this infrastructure as a code concept came into play with the cloud environment, whether you have your own cloud, whether you have private cloud, or whether you are using Amazon, Rackspace, whatever your cloud provider is. If you can convert your infrastructure into a code, then things are getting very easy. If in a configuration file, if you can mention the number of CPUs, memory, OS version, and the binary version, RVM version, sysctl configurations, or swap size, all these details of a server, if you can put it into a configuration file, then you can create the identical servers using that template. So which will give us benefits when we are trying to quickly spin up the servers. So that is also one DevOps movement. So in this slide that I'm talking about, 4 major movements that created DevOps. So infrastructure as a code is one of them. I think in previous presentation, Janaka was also touching a little bit about infrastructure code as code. So the other one is building continuous integration and continuous delivery pipelines. So which will automatically to test and push the changes, and we need to wire the security and other required compliance testing into this pipeline. So continuous integration and continuous deployment are very key things in DevOps. So I just want to know how you guys are practicing this continuous integration. Can you raise if you are practicing continuous integration within your organizations? Can you raise your hands? Okay, it's very few. It's the nature of Sri Lankan industry. We are still in the early days of continuous integration, but as an industry in Sri Lanka, we have to evolve to practice the continuous integration. In every day, a developer can commit to the software repository with his changes and integrate it with the code. That is really good. That is what we call the continuous integration. And then that continuous integration needs to happen. Every developer's changes needs to submit it to the commit to the main line. So which is really important. And on the other hand, continuous delivery and continuous deployment. When you are deploying the code into the production environment or pre-production environment or your regression test environments, nightly build environment, however the name you call it, when you are deploying the code into the environment, it should be automated. Even when you are provisioning the environment for your testing, that should also be automated. So that is continuous deployments. And then the other major movement here is running experiments, creating fast feedback loops, and learning from failures. So I will discuss more about creating fast feedback loops in my next slides. So throughout this DevOps movements, everything is targeted towards delivering software with quality and with a very high quality, and also deliver it within time. So those are the main aspects that we are looking at by implementing those practices here. So when you are implementing DevOps, I would personally I like to use this model, which is we call CAMS model: culture, automation, measurement, and sharing. So if it is a very small organization, a startup, let's say if it is a startup, you might be having a developer who's talking to the software, who's talking to the customer himself. or he might be doing the production deployment as well, if it is a very smaller company. But if it is a medium to large scale companies, then there is a distinction between these functionalities. We have a separate department for operations and we have separate departments for development. There are people who develop the software and there are people who manage the software in the production environment. So because of those silos, it's really hard to implement DevOps practices within an organization. So first thing that we need to implement is culture. We should build a culture where operations and developments are working together in order to, deliver the best to their customers. So instead of having silos, we are, building cross-functional teams to create software. So that is one good thing with the DevOps. And previously, I think if you were a sysadmin in 10 years back, you would know this. Where there was a time the sysadmins ruled the world. They have the production access, and they have they are the one who manage the production. So they consider themselves be kind of a privileged people. But now things have changed. Now there are environments. Where no ops are there. So operation folks are not there. It's all done by developers. Developers have the access to the ultimate production environment as well. So they manage the production environment. So the things have changed, and there are new roles have introduced into the organizations like DevOps engineer role. So all those things I will be planning to discuss. And this culture is really important because we need to build. We are not implementing a procedure. We are not implementing a practice like IDEs here. We are implementing a new culture. If you take Facebook, Google, Amazon, all the Etsy, all those major companies in the world are now moved to DevOps practices. They are DevOps companies now. In my presentation, I will touch a little bit on some of these social network engineering, social network companies, how they have implemented their pipeline, how they have delivered, how they are delivering the software to the customer. So basically, it's all about creating a culture where operations and operation people and the development people are working closely together. And the other important aspect is automation. With DevOps, we are expected to automate every repetitive task. Every repetitive task needs to be automated. So I believe engineers should not waste time on doing repetitive tasks. Then he's not an engineer. If you are an engineer should automate everything, because the engineering work is automation and execution work is just a script. So in modern world, if something is repetitive, definitely I believe that needs to be automated. So automation is a key concept in DevOps. You might have to automate your delivery or deployment or continuous integration, your build creation, your test, acceptance test, unit test, whatever it is, everything needs to be automated in a DevOps environment. We might not be able to get there overnight, but slowly, gradually, we should come up with a way of doing it. And then sharing. Sharing is also one thing where I talked about previously, where these how the operation folks needs to share their experience and knowledge and feedback with the development teams as early as possible. So I discussed this in my previous slides as well. So continuous delivery goals are low cycle time and high quality. Before that, continuous delivery is the backbone of DevOps. So that's why I picked the continuous delivery part here. Continuous delivery means like you deliver your software to the customer's hand safely with a high quality. So low cycle time is really important. If the development team takes 2 weeks to come up with a new feature, and if it takes another 2 weeks to deploy it in the production environment, it's a waste. So we need to eliminate that waste by doing various things, including automation, which we are going to cover. So that is one key aspect that we are looking for. So low cycle time. And then high quality. We need to integrate the quality into every step. So for example, if your product is supposed to comply to any security measurements that that is being introduced, then you need to integrate those security testing into your deployment pipeline. Then what will happen is you can automatically get that security clearance in your pipeline itself. So quality, when it comes to quality, it might be having various non-functional requirements. Non-functional requirements should be there, like performance, handling load, security. Many things can be covered, but ultimately the goal is to have a low cycle time and with a high quality products. So a couple of sessions that I did in Colombo, many presentations, I used this picture, because this is the picture of Toyota, how they build their cars, and they have a deployment pipeline, the Toyota belt. In their belt, how they build the cars is really fascinating. So there are many things that we can learn out of lean organization like Toyota. If you happen to read about how Toyota is manufacturing their cars, it's really fascinating. So their production line is very sophisticated, and the production line is always busy, and it's always delivering the cars to the to the customers. So that pipeline is its concept of a lean and Six Sigma concepts are there. So I just mention it here to get a very good opening for what I'm talking about in deployment pipeline. So here I have mentioned a small deployment pipeline, how we should deploy and how we should create a deployment pipeline. Initially, I believe every developer, every developer at least once should commit to the software repository on what they are developing. And then once the commit happens, the compilation should happen. And it will verify whether you have any syntax errors or not. Then compilation will automatically happen, and then unit test needs to be run against that build. So the unit test coverage is really important. When you are developing softwares, unit test coverage is really important. So at least more than 90% of the unit test coverage will give us a good clarity on the code itself, because unit tests are basically there to see whether code is behaving the way that developer is intended to behave. So it's really important to have unit test. In initial stage, when you commit to the software repository, after compilation, the unit test should happen. And then static analysis checkers like SonarQube needs to be integrated there. So I just use a sample tool there. For example, a tool like SonarQube might give you a good visibility on the code, whether there are duplicate lines or code coverage. Likewise, there are many aspects that it will measure. So initially, when you commit to the environment, all these compilation, unit test, and static channel analysis checkers should automatically run. And then build installers should also happen. So once it is done, then it should be deployed into the next in the next environment. Then you should have some sort of artifact, whether it's a .so file, .jar file, .net assemblies, whatever it is, you will have something. You will have something that can be deployed, so that you can get that deployable artifact, and then you need to implement it automatically. You need to deploy it into a next environment to do the automated acceptance testing. So acceptance test automation is also a really good thing, really important. It's very important in deployment pipeline. So when you automatically deploy to the environment, the acceptance test will tell you whether the business case is achieved through that code. If the business case is not achieved, then we will be having issues. So in a deployment pipeline, next step should be to automatically test this. And then after that, it should go to a capacity testing. It should deploy it into another environment to do capacity testing. So the capacity testing is also need to be automated. You might not be able to 100% automate the entire capacity testing plan, or maybe in your acceptance test as well. But the major portion of this testing needs to be automated. That is really a good thing when you are building a proper deployment pipeline in a DevOps environment. And then you might be having manual exploratory testing, where you give a UAT environment to a customer to go there and feel about the product, and then they can give their feedback. And then finally, you can release to the production environment. So in Velocity 2013, I had an opportunity to talk to one of few guys in one of the leading social networking organization. So the deployment pipeline which they have built is really fascinating. So every developer, at least every day that they are committing to the main line. And like in the same way, it goes through different stages. These commits goes through the different stages. For example, if we have come up with a new feature, that feature is tested in different environments using different criteria. And if there are any security conformances which we need to integrate, all these things are also integrated into this environment as a test. So there are no managers or no executive folks coming and ask you whether this test has this thing, whether this the build has this one, whether this will break. Nobody will ask any questions because all those questions will be integrated into the pipeline as a test. So that is the most fascinating thing. So that social engineering organization, once everything is done, they deploy initially to their own employees. They deploy the changes into their own employees, their own accounts. So once the employees are utilizing those features for some time, then they are implementing it to the wider customers all over the globe. So for many organizations, they have a sophisticated deployment pipeline. If you take Amazon, they hold a record for the deployments. They do every deployment in 11 seconds, every 11 seconds that they are doing a deployment. So they hold a record. In Facebook, they release twice a day. Many Google applications, they release at least 3-4 times a day, 3-4 times a week. How they release so fast? They release so fast because they have automated, sophisticated pipeline where every commit will traverse to the release state. For example, you might not want to deploy every commit into the production environment itself. But ideally, every commit should go in this pipeline till the pre-production environment. That's how it should work. In such way, you can decide which final commit that I'm going to put it to the production environment. Which I'm talking about is a kind of a very high level. Sometimes you might feel it's really hard to achieve. Yes, of course, it's really hard to achieve because if you take Facebook, Google, Amazon, those are different companies, and we are totally different companies where sometimes we only work for a specific product and we are not working in a software as a service method. So we are just building the software and handing over the software to the client. So we might be different from them. So there is an argument that some people are saying for startups, DevOps and continuous delivery is good, but for well-established organizations, it's hard. It's a myth. But why they say is there is a huge amount of changes that we need to introduce to get to this level. You have to invest a lot of time to automate all the acceptance testing. You have to invest a lot of time on automating unit testing and coming up with unit testing. Because in this type of environment, the quality engineer's role has drastically changed. Previously, the quality engineers were going through the systems and manually doing testing. But now, quality engineers are not there just to do testing. Quality engineers are automation engineers. They can automate the unit test. In some organizations, they have while the user story is built by the developer, the quality engineer is creating the unit test parallelly. So that's how some companies are operating. In some organizations, they do not have different organizations like Dev and QA. They have one set of group engineers. They can do both. They can do Dev and QA. So there are many startup companies like that, and they have gone very far with these practices, and they have achieved a lot of good things with those things. So the traditional QA engineer's role has changed, and which gave us a lot of good things where we can observe and learn from those things. So this is a small basic way of deployment pipeline. Then I would like to show a little bit of a more advanced one. You might not be able to see the entire thing here, but as the previous one, the same stage should happen: commit and compile, unit test, and all those things should happen. And then the QA environment provisioning should happen, or in QA environment configuration should happen. So that needs to happen using infrastructure as a code methodologies. If you run a Puppet service, if you have a Puppet service integrated to your software repository, you can have the server configuration in the software repository itself as a configuration. And when you want to deploy your new software into a new environment, you can get that configuration from the Puppet and from the software repository, and using a Puppet, you can create a new server, automatically provision a server. And then once you automatically provision the server, you can automatically deploy the code there. Like in the any stage here, that you can you can deploy the code as well as you can automatically provision the server. So it's all about automatically provisioning the hardware, if I am to be very correct, automatically provisioning the servers or the infrastructure, or whether it can be related infrastructure like network, many other infrastructure, load balancing. So automatically provisioning all those infrastructure, and then automatically deploying the code there and automatically running the test. So everything is done in an automated way, which will reduce a lot of time between production deployment and code completion. So the biggest problem that we face is that our code completion, after code completion, we take weeks to deploy it into the production environment. Our releases are like something to celebrate. When we do a release, we have a party, and we have after party, and we go to have a drink and all that, right? But it's not like in the companies like in Amazon or Facebook or Google. If they are to party after every release, they have to party 3-4 times a day, because they do releases that frequently, and they are introducing smaller changes. They are not bringing all those changes as a bulk and putting into the production environment. Have you ever seen that when you get up in the morning, the Facebook was totally changed than it was yesterday? It's not, because they are introducing smaller changes. So they are incrementally adding few smaller things. But you might be having many questions. For example, if you are a bank, if you are providing systems to bank, in certain regulations are there in banks. Banks, you might not be able to gradually introduce changes every day. There are certain regulations. In such cases also, DevOps has ways to handle it. I think if I discuss it more, it will be out of the scope of my presentation. But if you have such requirements, just please talk to me after the presentation. I will explain how DevOps can help there. So production environment provisioning, till the production environment provisioning, the entire thing is automated. The benefit here is, in every step, there is a feedback is generated and it's sent to the developer. In the commit stage, the feedback is sent to the developer and says, if the commit fails, and if the build, in the build stage, if the build fails, that the developer will get to know it. He will get to know that I am having some syntax errors in my code. Then he'll have to, fix it and put it again. So in static analysis checkers, there is a feedback that goes to developer. In automated acceptance testing, there is a feedback goes to developer. So feedback is early. That is very important. In modern software industry, what will happen usually in some organizations, what will happen is, especially in Sri Lanka, I have seen that you are working on some project, and then you build and you commit all these things, and you create it, and you ask the operation teams to handle it, put it to the production environment, and then you move to a different project. After 2-3 weeks, then operation folks are coming back and saying, okay, this is not working in production. Now, by that time, you have moved to a totally different project or totally different feature. That's because this feedback is not generating as early as possible. So in this situation, the feedback is generated as early as possible. when I commit the code into the software repository, once these automated acceptance tests are running, if it fails, I get to know that my code is not working. It doesn't deliver what business is expecting from me. It won't take months to get that to me because it is automated and it is automatically giving the feedback. So that feedback loop is really important. In DevOps, it's all about feedback.
Yes, two questions. One is about, we were talking about Facebook. So we may be able to understand small changes, bug fixes and things like that, but from time to time they do some major change, like let's say privacy policy changes or something else. So that does not come to the production environment until some time. So how do they handle situation like that from the regular release cycle? The other one is now in terms of this feedback. So when things are going okay, it's easier to manage. When there are problems in the feedback, how it can be managed?
Okay. Thanks for that question. It's really good because I think in that way we can build this conversation rather than I'm talking. So it's really good. I will answer the first question. So in Facebook or any other company where you are practicing DevOps, and if you want to do a bigger change, what they will do is they will decouple the release and deployment. What do you mean by decouple the release and deployment is, if you want to have a full change, we break it down to smaller set of changes. And then we deployed those changes until the pre-production environment. All these changes are gradually, we put into the pre-production environments, smaller changes. We keep adding those smaller changes. We test all those things, smaller changes. And by the time when we want to introduce the entire set of changes into the production environment, we are coming up with concepts like feature toggles, where all these smaller changes have deployed to the production environment. And then once all these changes have piled up, when it creates the entire bigger thing, we put release to the customer. Until that, we are not releasing to the entire thing to the customer, but they are in the production deployment pipeline till the staging environment. To do that, software architects and the software engineers need to really think about how we can modularize these changes. If it is a privacy change in a Facebook, to be honest, I don't know how that specific privacy changes that they have handled. But what I can suggest here is, if it is a privacy change like a big thing, then we can divide it into smaller changes. Privacy changes for photos, or maybe privacy changes to status. Likewise, maybe in any way, they can divide into smaller changes, and you can put all those smaller changes in the production pipeline until the pre-production environment, but not put into the production environment. Once everything is done, you can put it in the production environment. We call it feature toggles. So those feature toggles will help you to help you to release the thing at once, and it will help you to decouple the releases and deployments. So that is one thing. I believe if you have further questions, we'll discuss it too. And the other factor that you are asking is the continuous feedback is really important. Why it is continuous feedback when we have problems? Why we cannot face the feedback? Why we cannot face that, and why we cannot recorrect those things is our organizations are not ready to not set up to accept those feedbacks, because we have given set of user stories within our iteration. So if a feedback comes in, we don't have no room to get it. But we should design in our scrums and in our practices, we should have some room to get that feedback in, and give some time to allocate some time to react to that. Otherwise, what will happen is this feedback, if we are not fixing the feedback as early as possible, once it is gone to the production environment, sometimes customers might be able to live with it. We might be able to, when customers are trying to live with it, we put it to our backlog and we call it technical debt. this technical debt is increasing every time. After 2-3 years, the technical debt has created a huge disaster to the entire environment, and we will have to refactor the entire code. We should not go into that level. What we should do is, every time a feedback generates, we should have room, we should have time in our time. We should allocate time, and then we should react to the feedback immediately. If you have time to react to if the software developer has given the time to react to feedback, then the problem will be solved. So that's why I am saying this implementation of DevOps needs to have executive buy-in. As an organization, we should push this DevOps practices down to the organization. So, for example, then the engineers will have the liberty to react to the feedback. So, what I personally believe is, in our organization, in Pearson also, we are not really releasing the known defects. If the defect is known to us, we are immediately fixing it. Otherwise, it will create the technical debt, and finally we will be end up in refactoring, which will cost us much more time than the initial time. I believe, yeah. Thank you very much for that question. Then I will go to the next slide. I think my timer is actually, I have another 20 minutes time. So I will be discussing on engineering best practices on DevOps. First one is develop on mainline. If you take Google, 15,000 developers who are working in the Google Docs and related services like Google Spreadsheets and all that. There are about 15,000 to 20,000 people who are working in Google Docs. In one of their presentations that they have mentioned that everybody is checking into the main line. They do not have so many branches for different features. Usually what we practice to do is we have branches for everything. If it is a new feature, we have a branch. And if it is a new performance fix, we have a new branch. Likewise, we are branching this software repository into many branches, which is not a good thing. We should develop on main line. Whenever you want to do a release, you can have a separate branch for that specific release only. So which is very important. And this is kind of a controversial statement. I believe that you might be having many questions on this first line which I am talking about. We will discuss it more. And the second one is build your binaries once. Why we want to build your binaries once is, typically we have a syndrome called it works on my machine. When something goes wrong, production environment, something goes wrong, the developer said, it worked on my machine, I'm fine, it's your problem now. Why this happen is, sometimes we build several times in our pipeline for different environments. When you are doing a production release, we are building it again from the scratch and we use that new build to do the production environment, which is wrong. We should have a one build that can be deployed into any environment. Then you might ask me, then how can we handle the environment specific variables? If let's say a URL name, how can you handle it? Then you have to isolate the configuration from the software code. If the configuration is isolated, then you can get the same build and different configuration files for different environment. You can have one build and a staging configuration file that we put it to the staging box. And the same build with the production configuration file we put to the production environment. So it works, my machine syndrome will be not there anymore. So only build your binaries once, which is very important. And then deploy the same way to every environment. That is also one thing. Because when you are deploying to production in a different way and the staging in another different way, it is giving us a lot of problems, right? So we should deploy in same way. And also we should smoke test your deployments. When you do a deployment, if you can come up with a small test to check whether the application is up and running, kind of a small test, then it will save a lot of time in acceptance test area. Because in acceptance test, when you automate the acceptance test, it will run about 2-3 hours, right? Or maybe 5-6 hours. When this acceptance test is automatically running, after 5-6 hours only that you will get to know that your deployment is not working. Perhaps it may be because that after the deployment, the server has not started, right? So because of that, smoke testing the deployment is really important. Just a small test where to see whether this code is deployed and whether the service is up and running. And then deploy into a copy of production, which is very important. And one of the very good practices, I'm emphasizing the need of the copy of production. In our environment, in traditional software development, production environment is totally different from development environments or QA environment. We do not have same configuration across all the environments. This production is usually managed by sysadmins, which they claim to be kind of a very high privileged folks, that they are doing all sorts of changes into this production environment, but those changes are not depicting in the pre-production environments. Then when you test thoroughly in your environments, stage pre-production environments, your code works. But when you put it to the production environment, it doesn't work. Because the production environment and these environments are not identical. So can a human make this identical in manual way? No, you cannot. Let's say if in a server, if you take the sysctl command, thousands of configurations are there in a server that will change the values of how server is behaving. So it's really hard in a production environment, manually creating identical environments. So you cannot create identical environments manually. That's why you need to have the infrastructure as a code. You need to put all the configurations values of a server in one configuration file, and that using that template, you will need to create many servers. With that template, you can create your staging servers, you can create your production servers. It's just changing the DNS and few other values only. The environment will be identical. Ulimit, let's say ulimit in a server, if the ulimit is identical, will be identical across all the environment, if you are using the infrastructure as a code. So the other one is each change should propagate through the pipeline instantly. Every commit should go through the pipeline. Ideally, a developer should commit once in a day, and that commit should go to the pipeline instantly. And it will go through all those processes. And let's say if one commit is traversing through the pipeline, and then somebody else is committing, then the other guy can wait until this one is completed. And then by the time another guy commits, then we can put the latest commit to the production environment. That doesn't matter. So you don't need to have all the commits, but the latest commits definitely should go through the pipeline to its desired state. So if any part of the pipeline fails, we should stop the line and immediately roll back everything, and then we should try to fix it. So when there are commit conflicts happen, we should build a culture where these developers get together and sit together and finalize this and come up with the proper commit. Which is why we need to have a culture developed within an organization where we can have organization where we work very closely. If the commit conflicts happens, then we can resolve it within the engineers itself. So in this environment, breaking the build is not a crime. But if the proper test is not in place to track it, then it's a crime. So I think I talked a little bit about engineering best practices on this one. And next I would like to talk about a few infrastructure management principles here. So I've talked about this in my presentation, but just mentioning here, the desired state of your infrastructure should be specified through version control configuration. As I said, server is now a code. That code needs to be installed, or code needs to be stored in a software repository. So that code, that configuration needs to fetch, we need to fetch from that repository, and we need to come up with a set of servers so that we will be having identical servers in many environments. And the other one is infrastructure should be autonomic. That is, it should correct itself to the desired state automatically. Let's say if a developer if a sysadmin goes to the production environment and change a value in the server, automatically it should correct it to the desired state. How we can do is tools, configuration management tools like Puppet, Chef, Salt, CF Engine, Ansible. Those tools are capable of doing it. Those tools can automatically correct the value changes. If we are introducing a change to a server configuration, let's say ulimit change, if you are introducing, we should introduce in this same pipeline. We should change that value in our infrastructure as a code file, and then we should implement in the pre-production environment, and we should do all those tests. And once it is confirmed, only that we should do it in the production environment. You cannot just go into the production environment and do a change and see if it works. No, it doesn't work. We cannot do that like that. So that is not a good way of handling things. So infrastructure should be autonomic, and it should correct itself to its desired state automatically. And then you should always know the actual state of your infrastructure through instrumentation and monitoring. Instrumentation and monitoring is really important, whether it can be CPU, memory, disk space, network bandwidth, whatever it is, everything needs to be properly monitored, and we should react to any changes that are happening to that infrastructure. Let's say a disk is filling 100%. That is a change to the environment. We should be able to immediately react to that change. If we have proper monitoring and instrumentation in place, we can do that. So infrastructure management is really important in a DevOps world. So my entire session is about continuous delivery and DevOps, which is a very broader topic. I'm having really difficulties in explaining everything in this domain. So I thought of bringing most valuable concepts here. If you have further questions, we can talk about it more. And then next, tools and technologies. So tools and technologies which are mainly in DevOps are version control and artifact repositories. You might have worked with SVN, GitLab, or in IBM they have a software repository called ClearCase, which is really good, and they are coming up with a stream-based software development rather than branching. So rather than branches, they have a new concept called stream, which is really good. So there are so many version control systems. As a DevOps engineer, the DevOps engineer should be capable of identifying the pros and cons of all these, many of the major software version control systems, and then use the best one appropriate. And CI/CD tools like Jenkins, TeamCity, Bamboo, and Go. I personally like Go because it has a very good way of showing this in a dashboard. In a pipeline, you can see the pipeline, how it behaves in a dashboard. Then any developer in his desk can see if you have a screen over there that my commit is now at this acceptance test level. So he can see that. So which is really good. And static analysis checkers and automated test frameworks, really important. Now we are moving into acceptance test driven development methodologies. So automated test frameworks are really important here. And also security scanning tools. If you are building systems for banks or any other financial organizations, the security is a must. So all the security tests needs to be integrated into the pipeline. So there are tools to do that for the security scanning as well. And then automated release deployment tools as well. People are coming up with different tools for their own needs, but there are some standard tools as well. If you take a Factor, Factor is a really good tool. You can orchestrate all these steps using Factor. And configuration management tools, I was talking about many times on this one, Puppet, Chef, CF Engine, Salt, Ansible. So those are really good technologies in this one. And containerization and virtualization technologies. I heard Janaka was talking about containerization technologies. I think he was talking about Docker, I believe. But anyway, this containerization and virtualization is a really good way of handling things, because then you can come up with a server or come up with a container where you can install all the software which you created in that container, and you can push that same container to the production environment itself. So nothing will be changed. The underlying infrastructure configuration changes, differences will be not there, because we are moving the entire set to the production environment as a container. And structured storage text file formats like JSON, YAML is also needed. So it's a wide spectrum of tools and technologies. I thought it's worth mentioning here. And then finally, DevOps engineer. I got a request to talk about a little bit about our DevOps engineer as well. In Sri Lanka, we do not have a lot of DevOps engineers. So I did not introduce myself at the presentation. So I just wanted to introduce in this slide about myself. Which is usually which is not usual, but I'm application engineering manager for Asia Pacific region and EMEA region. I manage 2 teams in both the regions. Both these teams are having a set of DevOps engineers, about 40 engineers that I manage across these regions. And I have been working with DevOps for the last 3.5 months, 3 to 4 years, I believe. Last 3 to 4 years, I've been working in DevOps, as well as I do consultancy work for many organizations in Sri Lanka as well. So I wanted to create an awareness on the DevOps engineer role in Sri Lanka. If you take in Google, Facebook, they are the highly paid engineers than developers and than traditional operation folks. In Sri Lanka, we still do not have a lot of DevOps engineers who are capable of building DevOps pipelines. So software engineering skill is a very important thing for a DevOps engineer. If you are a traditional sysadmin, that you haven't done any software engineering and you hate software engineering, I'm sorry to say that your world will be changed very soon, because you will have to move to software engineering world. The software is actually eating the operations world. So if you want to become a DevOps engineer, software engineering and scripting skill is really mandatory. And infrastructure as a service, platform as a service, software as a service skills are really important. And also testing skills. In traditional sysadmins, the testing was not there for traditional sysadmins. They introduced many changes to the production environment without testing. So it is not there. And strong communication skills and vast sysadmin knowledge is also there, should be there. So if you take in 2013, in left side, you can see that 44% of the engineers were doing hardware, and 38% of the engineers were doing 40% of the engineers were doing hardware in 2013. But now things have changed. Now it's the difference is minimized. Now we have engineers who are doing both. Because software and hardware is now becoming one thing, with the concepts like infrastructure as a code and tools like Docker and all that. So I have, according to this, I have another 5 minutes because we might have started a little late. I'm not going to discuss any of these things. If you have any questions, please ask me now.
So you said every production server should be duplicate the UAT and the staging. So there might be a cost. Say we can have the same RAM and all the other hardware component of the UAT and the staging cell. So what is the solution?
Yeah, I believe the one thing is, if you are running on a cloud, the solution is there, because in a cloud environment, you can spin up a server whenever you want and you can shut down the server. So if it is a cloud environment, the cost is not a big aspect. When you want to spin up a environment for the new commit, you can spin it up and you can do the testing and then you can shut it down. But if it is a traditional environment, traditional data center environments, which is very hard, then if it is virtualized, then in the virtualized environment, we can come up with our own scripts to talk to the APIs in the virtualization environment to automatically spin up the servers. That is a one way of handling things. So that whenever we need to have we can have a pool of hardware, and then we will spin up a server for that pool, out of that pool for the specific test, and we shut it down again. Because the configuration is anyway there in the configuration file. It's just a matter of getting that configuration file into the virtualization environment and automatically spin up a server. But the other way of handling this problem is you can have scaled down environment. Unless you are doing performance testing for acceptance test or any other test, you can have a scaled down environment where you might not have the same memory, same RAM, but the configuration should be a scaled down version, not a totally different version. Let's say the U limit in the main environment, if the U limit is 10,000, the second server, in the pre-production server, the U limit should be scaled down proportionally to meet that requirement. So in that way, we can achieve something somewhat better. But ideally, only for performance environments, that we should have identical environments that you can automatically spin up and you shut it down once it is done. But for any other acceptance, QA, and any other testing, you can have a scaled down version.
Yeah, in this testing pipeline, what about external services, databases? How do you manage changes across those?
Yes, which is a very good question. Let's say in this deployment pipeline, there are 4 components that comprising of software: executable code, configuration, host environment, and data. So there are 4 items. All these 4 items need to be version controlled. So if it is a database related change, that change database also in a cloud environment. If you take databases like NoSQL, NoSQL database, Mongo, Cassandra, those database configuration can be versionized. But in a more traditional software, databases like Oracle, it might be a little hard. Yet, we'll have to come up with a ways to put those configuration files into our software repository, and whenever we want to make that changes, we make that changes in the configuration file, and then we deploy that configuration change. But in your questions more broadly, if it is something kind of a patch upgrade in a database might not be, we cannot put it into the version control, but we'll have to do all the testing and in different environments and then do the production environment. They are also, if you do a new patch upgrade, you need to do the acceptance testing. You might have not changed anything in the code, but you have applied a new patch. Then the acceptance test suite automatically should run. Then we are very confident about our environment, then we put it to the production environment as well. So any data changes also should be there. And we should come up with the mechanisms to create test data as well. That also need to be automated. Creating test data. Yeah. So if you have any questions, please reach out to me. I'm in LinkedIn. My name is Sanjeewa. If you can search, you will find it there. And if you have any questions regarding this DevOps continuous delivery space, please reach out to me at any point. I'll be more than willing to help. Thank you very much for being here. Thanks for your time.